start with a set of natural numbers and consider two different ways of ordering that set. So the first way is the usual way. And now consider this weird ordering where you say the smallest number is not going to be 0. It's going to be 3. That's the smallest. And then after that, things are just as usual. So after 3 comes 0, and then 1, and then 2, and then 4, and then 5, and we just keep going. So a different way of ordering that same set. Now, we know, of course, that the things here are just as many as the things here. But there's another nice feature that these orderings have, and that's that they're isomorphic to one another. So because the sets are the same size, we can establish a 1-1 correspondence between the elements. But in this case, because the orderings are isomorphic, we can establish a 1-1 correspondence which preserves the ordering. So one in which we never have lines that cross. So what we say in this kind of case is that those two orderings are of the same type. So one way I like to think of it sometimes is that they have the same shape. So in both cases, it's an ordering that has this shape. Contrast that with a different way of ordering the natural numbers. So suppose that we say, OK, instead of starting with 0, we're going to start with 1. So 1 and 2 and 3 and so forth. And then what happens with 0? 0 goes at the end. So in this way of thinking of the natural numbers, there is a biggest one with respect to a weird ordering. And that one is 0. And then you can ask questions about it. You can say, for example, well, what's bigger, 0 or 17? Well, 0. But if you tried to ask what comes immediately before 0, then there's no good answer to that question. There is no last thing before 0. But that doesn't mean that the ordering isn't well defined. So in particular, if you take any two numbers, there is a good answer to the question, which one comes after the other in the order, always. And now what happens with this ordering is that it has a different shape. Instead of having that shape, it has this shape. And as a result, the orderings are not isomorphic to one another. So although it's possible to establish a 1-1 correspondence between this set and this set, it's not going to be like this one where the lines don't cross. So instead what you need to do is something like this. You can assign 3 to 0, and then do that. And the lines crossed. So those orderings are not isomorphic to one another. So the only thing that we're going to be concerned about now is not the specifics of orderings, but the order types of order.